certification. Thank you for joining us today. This webinar is being given by MET Laboratories. MET is a leader in the testing of electrical and electronic equipment for environmental hardiness, product safety, and electromagnetic compatibility. MET operates world-class labs in Baltimore, Maryland, Santa Clara and Union City, California, Austin, Texas, and also runs operations in China, Taiwan, Korea, and Italy. This webinar will run 30 to 45 minutes with an additional 15 minutes for questions and answers. Due to the number of registrants, all attendees will have their phones muted. If you have a question, please type it in the questions area of your control panel. We will attempt to answer all questions at the end. Today's webinar is being presented by Jim Reed and Mansi Bundewad. Jim is the director of MET's Telecom Lab and manager of MET's Meter Accuracy Lab. Mansi is the regulatory EMC lab manager for MET Laboratories. At this point, I will hand over the presentation to Jim.
Thank you, Barnaby. Hello, everyone. This is Jim Reed. As Barnaby said, I'm the manager of the Meter Accuracy Lab here in the Baltimore office, and we're going to focus on our ANSI watt-hour meter testing and certification programs that we offer here at MET. And so with that, we'll go ahead and get into it. Quick slide here I wanted to add to just go over a very few of our accreditations, primarily as it pertains to the meter testing program. MET is accredited independently by A2LA for testing the ANSI C12.1 and C12.20 and a few other metering to a few other metering standards. MET is the first nationally recognized testing laboratory for product safety certifications and listings. MET is also the only laboratory at this time recognized by Measurement Canada under their RTO1 recognition program for testing meters which have been previously certified and have been modified for one reason or another. Our data is recognized by the folks up there in Canada at Measurement Canada. We also are a telecommunications certification body for the FCC, and that involves our telecom lab, our EMC folks, our wireless laboratory. We're a certification body, a CB, recognized by Standards Council of Canada, and we are recognized as a laboratory able to test submeters for the Maryland Public Service Commission, as well as the New York State Department of Public Service, and a few others, but those are the two primary that we normally deal with. Okay, getting into the presentation today, we have a list here of the 38 tests out of the ANSI C12.1 standard for accuracy testing of electricity meters. The focus of the presentation, as we said earlier, is going to be the accuracy testing out of C12.1 and C12.20. Basically, the 38 tests that you see here are what would be tested in our laboratory, and they're very similar from between those two documents, C12.1 or C12.20. The primary difference being C12.20 has a tighter accuracy. So, for instance, if you have a meter that's a 0.2% accuracy class, that would be tested to the C12.20 standard and in turn that standard references back to some of the criteria out of the 12.1 standard. And there's some other things having to do with Blondel, non-Blondel, but essentially that's the difference between the two. And the tests, although some are varied between the two standards, are pretty much what you see here with these 38 tests. So this is what our focus is in the laboratory. And the way we're divided up here, the way our metering program is divided internally at MET, my group handles the meter accuracy testing, along with the environmental tests in terms of vibration, temperature, cycling, humidity, those sorts of tests. And Monsi's group handles the EMC types of tests. So your voltage interruptions, your magnetic field and electrical field, either emissions or susceptibility type tests. Those are performed in Monsi's group. And one other thing to note here about the 38 tests, you see 8 tests there denoted with an asterisk. Those 8 tests are considered series tests by the standard. And there's some debate on whether or not you need to sequentially go through those 8 tests, starting at test 15, 16, 17. That's the way we handle it here at MET, just mainly for consistency's sake. But the main point I want to make about that is those series tests must be performed on the same 3 samples. So at the very least, the standard requires that 3 samples go through whatever test is applicable here out of these 38 tests. So if you have one meter type, one type of configuration, then 3 samples would go through each of the applicable tests. But it's important to note that the same 3 samples need to go through these 8 series tests. So you're not only looking at does the meter meet the criteria of those individual tests, but you're also looking at accumulated stress. And does that become a factor as you run through those 8 tests? Whereas the other tests, you're allowed to use different samples. Same build of meter, but different sample sets can be run concurrently. And that really helps expedite the testing program. So those are the overall tests. And what we have here at MET essentially are 3 basic meter test programs. So the top bullet point there is the ANSI meter certification program. And that is a program whereby we are running testing, again, 3 samples per test, whatever is applicable, through all of the applicable tests. At the end of the successful completion of that test program, you would receive a report of compliance, and even a certificate if you had requested one. The MET meter certification is basically very similar to the ANSI meter certification, but we've added a bit there in MET for some of our folks that may request it or have buyers that want to see a bit more check and balance, if you will, by an independent organization, MET, of course, in this case. So the MET meter certification program, we will take the 3, I'm keeping it simple, just saying 3 meter samples, same build of meter through all the applicable tests. You'll receive a report of compliance after a successful completion of that test program. And beyond that, there would be an annual continued compliance program in place. So what that is really is that's where the check and balance comes in. So what we're doing after 1 year time, if there are no changes to the product at all, at the very least we're going to call in samples and run some fairly quick accuracy tests if nothing else has been changed, just to be sure that over time, we tested the sample 12 months, maybe more ago, over time the samples that are coming off the production line still at least continue to be accurate. We're looking to make sure of that. Were there any significant differences in the accuracy results from a year ago? Sometimes that can clue you into some differences there. Also, if the meter is changed, there are hardware changes, firmware changes, for example, that is communicated to MET by our customer, the manufacturer, and we'll dialogue. And determine whether or not those changes are significant enough to affect previous compliance from the original test program. If that's the case, some limited testing may need to be rerun. And it's all, again, it's all in an effort to assure the manufacturer's buyer that there's a third-party entity looking at the changes to the meter as time moves on. And further from that, the manufacturer is then allowed to add our MET meter certification mark that you see there on the right to either the meter or their brochure, use it basically nearly however they want to use it. And our third type of program is simply a customer-specific test program. If you have a meter that has been changed, some folks have been in the business forever, and they know that, okay, this change is going to affect these couple of tests, 2, 3, 4 tests. We really just want a quick test program on X amount of samples to show compliance with these particular tests. That's fine. That's not a problem. We'll certainly do that for you as well. And that's what our customer test program is about. Maybe you have a test program that goes beyond what's required by ANSI, that sort of thing. In that case, we'll run our testing upon completion of the successful test program, depending on your test pass-fail criteria. A report of compliance is then issued. So that's the 3 basic test programs we have here for our metering. So getting into a bit more of the detail of the ANSI C12 requirements for our meter certification program. How it starts out, of course, is folks will contact us. We've got a product. They'll submit a request for quotation, and the people here at MET will take a look at the meter. What is the configuration? Is it a family of product? Does it have wireless modules installed? All the details about the product itself. A quotation will be submitted, a test plan will be developed, and we'll get into a test program. Minimum sample of 3 meters. If you have a family of products, for example, you may have different current ratings. It may be single-phase or polyphase type meters, but the metrology is essentially the same in the product, so it's a family. There may be more than 3 meters per test that would need to be tested. And C12.1 has some criteria on how to determine, some basic guidelines on how to determine how many samples should run through each test. So all that's looked at up front. Upon completion of the test program, we are submitting, or giving you rather, the detailed test report. The report will have all the details in it in terms of the configurations, what the product was, the samples tested, firmware revisions. It's not just the test data, or it's not just a checklist of compliant versus not compliant. You're going to have all the details in the test report, because at the end of the day, at the end of the program, really what you're going to walk away from us with is just that report of compliance. And that's got to carry a lot of weight for your buyers, of course. For the MET meter certification program, your product will also be maintained on our database, on a database of certified meters on our website. So that's a pretty convenient tool. It can be for your buyers to sort of do the reality check and get on our website and see that your product is, in fact, listed there. Talked about the continued compliance program annually. That's just for the meter certification, the MET meter certification program. And, of course, if there are modifications during the course of the year, the continuing compliance program is an annual thing. But as changes happen to the product, and they will, the intent is that the manufacturer and MET dialogue about it and come to the consensus on what may need to be retested, if anything. Many times the changes are do not have anything to do with what the requirements of the standard put forth. So it's all about the communication between MET and the customer there. So some of the challenges when testing smart meters, the standards, for the most part, were not really written for the smart meters as we see today. That's changing. Of course, ANSI committees and working groups are constantly working toward keeping up with technology and those evolutions, but that takes time. And so we've got the standards here as they're written today, C12.1 and 12.20, and we have to take into account things like the wireless modules. Are we going to transmit at full power to make sure that that isn't going to affect accuracy? Service switches, we need to make sure that they operate during certain points of the testing. We would request that support equipment be sent along with the meters as necessary so that we are properly operating the features of the meter during testing, before, after, during, depending on the test. But the point is that we are operating the meters, for example, the service switches, communicating either locally with a computer loaded with software or the website, what have you, that we're looking at registers, not just at the meter, but also remotely. Case-by-case situation, depending on what the product actually is. But these are some of the considerations that we've got to get into when we start up a test program. And all this is looked at, of course, when the request for quotation initially comes in. Submeters. Is it a submeter? There are a lot of variations there, and these standards were not written for submeters. But having said that, the public service commissions and other folks out there that are knowledgeable in meters and want to see the accuracy of submeters tested to something, they refer back to the ANSI C12.1 standard. So, with all the different variations of meters, it's a lot to consider what would be applicable out of that standard. How would we go about configuring for test and that sort of thing? Is it a direct connect submeter? Does it have CTs? Does it have VTs? That sort of thing. All this has got to be considered. So there's a lot of challenges and considerations getting into a test program. The acceptance testing for modified meters, we talked about. I talked about it some earlier. Anytime there's a change to the product after the original compliance, you want to make sure that you're sort of bouncing the question off of us. This is what we changed. How does it affect it? We feel it may affect this, or we feel it does not affect the meter because. That's the type of communication that would go between MET and the manufacturer, and we come to a consensus using engineering judgment on what may or may not affect previous compliance testing. If there are tests that need to be run, some subset of tests from the original suite of compliance tests, 3 samples would need to go through at a minimum. Same as the standard. We try to follow exactly what the standard requires for all test cases. So I talked about some of the other things. Generally, meters being changed, hardware, firmware, communication, AMI modules are added to a legacy meter. There's all sorts. It's really a case-by-case basis, but there are all sorts of different changes that happen during the evolution of a product. And this is usually some time after the initial compliance is performed. So in general, just some of the conditions that would affect the accuracy: temperature and humidity cycling, extremes, noise being generated, it's an intentional radiator, AMI module, wireless module within the unit that could cause problems with the metrology, depending on how that's configured into the meter product. Current faults or line surges, voltage spikes simulating sort of nearby lightning strikes or fault currents that may run through the meter or in close proximity to the meter. Allowing the meter to acclimate to the environment. So essentially you don't want to power the meter on and start taking accuracy measurements right away. Typically there's some warm-up period that you need to consider before you get into the accuracy testing. Improper calibration of the meter at test bands. The first thing we do before we get into any of the testing at all is run a performance verification, full load, light load, power factor of the meter, just to make sure that that is compliant to the standard and it appears that the meter is properly calibrated. Sometimes right out of the gate, we'll find certain meters do not even meet that criteria, and that happens. But we don't want to get too deep into a test program before we find out that's the case. Harmonics, obviously the voltage and current harmonics can affect the equipment. Harmonics are not currently part of the ANSI requirements, but they're coming down the pipeline, so they'll be in there shortly. The wireless modules, sometimes we'll see those communicating on the optical port that many times, most times I'd say, we use for picking up the KT pulses that we use to calculate the energy consumption coming from the meter product. So you have to be aware of those sorts of situations, otherwise it'll look like the accuracy is completely out of whack. The most common failures that I see in my lab, I'll let Monsi talk about the EMC failures, but what we typically see in the accuracy lab and running the environmental simulation tests, we see some of these. It's not in any particular order. Any of the tests could fail, of course. Any of those applicable 38 tests could fail. But I talked about it just a bit ago, the full load, light load, power factor failing right in the beginning of the test program or before or after any of the tests are performed. We see that quite a bit during the course of the test program. Load performance testing, power factor tests, test 3 and 4 out of the ANSI standard, running under the full range of load conditions. Many times you'll see failures at the low end and sometimes even the high end of the, depending on the rating of the meter. Wireless modules installed on one of the circuits of the one side circuit of the meter could affect meter losses. Sort of a known issue, but we do see that on occasion. The service switches, either fragmenting or welding together during the 7,000 amp overcurrent test out of test 20 of the standard. That's a test where you've got to continue to operate properly and not be damaged, essentially. There is a higher level test in there as well where you can fail to operate, but you've got to fail safely. It's better if you pass everything, but this is the one. If we're going to see a problem, many times we'll see it here because you really can't have any kind of fragmentation or have the product, the switch in this case, not operate, not actuate on command. Of course, the operating temperature and even the relative humidity at 85 degrees C, we see cases where the meter will sort of wink out and not operate at usually at one of the extremes, either low temperature or high temperature. Test 32 through 35, the mechanical test, the vibration, the transportation vibration. Most of the time, the meter will operate properly before and after these tests, but we do see quite a bit of, as a result of packaging in particular with the transportation vibration and the drop, where we'll have mechanical damage, a cracked tab or a dome or something of that sort could be an issue. Discoloration of displays, the polymer displays under the Xenon Arc test out of test 36, the weather simulation testing. We see that quite a bit. It's a 14-day test. Essentially, that pretty much equates to about 3 months of Florida weathering, just sort of rule of thumb. So it's about a 6-to-1 laboratory accelerated test in the lab. It's not very long, so if you have, for example, if you're a utility that may have problems with yellowing or discoloring of the meters or domes, you may want to run a program that goes a bit longer than that. And on occasion, this has not been too much of an issue lately, but rain tightness tests, we may see some intrusion of water within the meter itself. So with that, I'll go ahead and pass it over to Monsi and let her discuss some of the EMC tests that we're talking about.
Thank you, Jim. Hello, my name is Mansi, and I'm the Regulatory EMC Lab Manager. I'm just going to speak about some of the EMC-specific tests within the ANSI C12 standards. So here you can see a list of the EMC-specific tests within the standard: insulation, voltage interruptions, effect of high voltage surges, magnetic field, current surge in ground conductor, electrical fast transient test, oscillatory SWC, radio frequency interference, conducted and radiated emissions, and electrostatic discharge test. So some of these tests that you see on this page, you probably are already familiar with, because these are some of the tests that are routinely required for most commercial products. Now, some of the tests that are different in the ANSI C12 standard are the test 18, effect of external magnetic field. So basically, this test is not at all similar to the magnetic field test that is performed under 61000-4-8, where you immerse a product into a magnetic field. But what the ANSI test calls out for is we have to use a 6 feet by 6 feet conductor and generate 100 amps of current into this conductor. You then place your meter within close proximity to this coil. You place it 10 inches from this coil, and then you basically test the effect of magnetic field on your meter using the proximity test method. So that is something that's different here in ANSI, and it's partially unique because no other international standards require you to test this way. The other test is effect of current surge in ground conductors. Now, this test is also something that is only required by ANSI. Most other commonly referenced standards do not call out for this spec. So what this test is the name itself says it's a current surge. Although it says it's a current surge, it's not your typical lightning surge, where the lightning surge has a test parameter of 1.2 microsecond rise time over 50 microseconds, whereas this current surge is specified as having a rise time of 20 microseconds and a half time of 50 microseconds. So as you can see, this surge has a lot of energy within it, and the test levels for this current surge is typically 20 kiloamperes. So that's some significant test right there. So the way this test is done is they're trying to simulate a lightning strike that happens on a ground rod when this ground rod is placed somewhere close to your metering product. And the way we simulate this test in the lab is we have a surge generator which will generate this impulse of 20 microsecond by 50 microsecond, and we have a conductor which is grounded into which this impulse is generated. Your metering product would be placed very close to this conductor, about 1.5 inches away from this conductor. And then what the electromagnetic energy, which is created from that impulse, we are subjecting the meter to that electromagnetic energy and observing it for any failures. Typically what we see during this test is either the meter will be okay, sometimes the display will go out, or we might have component damage as a result of this test. But this test is only required for self-contained meters. So if you have a product that is not self-contained, meaning you're using external current transducers, then you're not required to go through this test. Now, some of the common EMC test failures that we see here at MetLabs are, I've listed them in the order of most commonly failed tests. So the most common failure is on conducted and radiated emissions. As the name suggests, this is an emissions test where we subject or where we perform emissions testing on your product. And the emissions testing is performed against the SCC Part 15 limits. But the important thing to note here is that this emissions test is performed against Class B limits, which is for a residential product. So even though your product may or may not be used in a residential environment, we are still required to test it against the Class B limits, which are more stringent than the Class A limits. The next common failure we see is test number 17, effect of high voltage line surges. So although it says effect of high voltage line surges, this test typically comprises two different surges. One is the combination wave surge, which is simulating a lightning strike and the transients that are induced because of this lightning strike. And the second surge test is a ring wave surge test, which is, this type of transient is caused due to switching of loads, switching of reactive loads. So these are the two types of surges that we are required to test. The other important thing to note that is for this test, the test amplitude is 6 kilovolts, which is really very high, because most of the common, the other tests, commercial tests that we perform only go up to a maximum amplitude of 4 kilovolts. So that is something that you should consider. The other failure we see is effect of electrical fast transient test or burst test. So this again is a test where if you have a commercial product before you market it, this is one of the tests that you would have to go through, the fast transient test. The difference here is instead of testing at a standard typical level of 1 kilovolt or 2 kilovolts, here we are required to test at a level of 4 kilovolts, which is very high. And most commonly, the failure we see is either the display will go out, the display will flicker, or we'll see that the energy readings, the watt-hour accumulation on the display will keep fluctuating as the test goes through. Some of the other failures we see are if your product does not have a display, we need to be able to monitor the watt-hour reading. So what we would do is we would connect it to a laptop which has some proprietary software, and we'll monitor the laptop to see what the reading is for the watt-hours. So when you're performing the electrical fast transient test burst at 4 kV, sometimes what we see is the communication failure happening as you're testing for the burst test. So those are some of the failures that we see on that test. The other test that we see failures on is a effect of radio frequency interference, which is test number 26. So basically this is a radiated immunity test wherein the meter is subjected to a radiated electromagnetic field at a level of 15 volts per meter. And what we are doing is we are monitoring the display to see that there should be no deviation in the watt-hour energy reading that is being displayed. And if there is any change in that reading, it should not be more than one least significant digit. So typically what we would see on that test, the failure we would see is that the reading just continuously fluctuates and keeps on increasing as we go through the test. So that is something that we would see on that test. And lastly, the insulation test, which is basically a dielectric test where you're testing for the insulation between the current carrying parts and other metallic parts of your product. And the requirement states that the leakage current limit is 5 milliamperes. And sometimes some of the products are not able to meet that requirement. So continuing with the ANSI test failures, what are some of the things that you should consider before sending a product down for testing? So starting with the surge test. As I mentioned previously, the surge test is performed at a very high amplitude of 6 kilovolts. And not only is it a combination wave surge test, but there is also a ring wave surge test. So there are two components to that surge test. The other thing to consider is that the surge test, the combination wave surge test, is performed at 6 kilovolts and 3 kiloamps. It is important to take note of the current, 3 kiloamps, which implies that the impedance at which the test is performed is 2 ohms and not 2 or 12 ohms as is commonly required for the other international standards. So this is something that we see all the time. We start off with series testing. We go through insulation test, voltage interruptions, and a surge test. Mostly the combination wave test is when we see a failure, where we would see some of the fuses open, we would see the display go out. So those are some of the things that we would see mostly on a combination wave surge test. So you definitely want to make sure, what sort of surge protection devices you're using, whether that surge protection is adequately rated to handle 6 kilovolts and 3 kiloamps. You want to make sure of those things. For the emissions testing, has the product been previously tested to FCC Part 15, Subpart B? Again, the important thing to note is, as you keep designing and developing your product, you want to make sure that at each stage, at each development stage, you want to just make sure that the emission profile of your product would be okay, that it would meet your FCC Part 15 limits, and particularly Class B limits. So you could either do this on your own. All you would have to do is get a spectrum analyzer and measure for conducted emissions. You could use some near field probes and try to do some radiated emissions work on your end. The other thing you could do is you could send it to some test labs. You could use local labs. You could send it to us, and you could perform conducted and radiated emissions testing just to get a sense of whether your product would meet this requirement. Then, is the product that is sent for testing a good representation of a typical installation? Now, this is something that you should always make sure that you let the test lab know ahead of time. So we come across cases where we have a product, we are going through testing, there are some failures noted on conducted emissions, radiated immunity, and somewhere during that time we come up and hear, oh, by the way, this is not how the product would be installed. When it's installed in an actual installation, we would have it shielded, the cabling would be in conduits, it would not be just out in the open. So these are some of the things we hear. So this is something that we would like to know before you send the product for testing. And we want to make sure that the product you send for testing is prepared in such a way. If your product does have a display and a laptop is used to monitor real-time watt-hour readings, are there going to be any communication issues during fast transients and surge withstand capability test? So this is something that I mentioned previously. If you have a product that does not have a display, and we are relying on the use of a laptop to monitor for the watt-hour readings during the test, this is something we commonly see wherein during the fast transient test and during the SWC test, we would see some communication issues. We would see the display being frozen up on the laptop. We would see the communication completely stalling during the test. So whenever you're submitting a product that does not have a display, you want to make sure that there would be no communication issues during this test. So you want to make sure that adequate transient suppression devices are being used. You could use switches in line before the laptop. So anything else you could do to make sure that there would be no communication issues, you should take care of that. The other thing to note is, what is the resolution on the display? Typically, when we are testing for any immunity test, that is what we are watching to see if the display does not change by more than one least significant digit. Now, sometimes we have seen cases where the resolution on the display could be like 4 or 5 digits, which are representing watt hours. Or sometimes we see cases where a particular product has like several digits being displayed, maybe up to 8 digits being displayed with up to 5 digits, and then there is a decimal point and 3 digits after that, which comprises your display resolution. So sometimes too much resolution, if you have too much resolution, if you have too many digits after the decimal point, what we see is some of the tests like fast transients, radiated immunity, wherein you see that the watt-hour accumulation is changing or increasing If you have too many digits after that display, we see that happening quite a lot. So when you send your product for testing, you want to make sure that you have enough resolution, but then you do not want too much of a resolution that would cause some issues on tests. Is there any voltage sensing circuitry that needs to be disabled for insulation testing? So sometimes this is one of the first series tests, which is test number 15, insulation test, wherein we are checking for the, the dielectric. When we perform this test, sometimes we are not aware beforehand of what the schematics is or how the product is designed. We will go ahead and perform the test according to the standard. So we will test it between the current carrying parts and the other metallic parts. Sometimes you might have some voltage limiting devices, any surge suppressors that is parallel with the circuitry that you are testing. And of course, in that case, you are obviously not going to meet the requirements with the leakage current being less than 5 milliamperes. So if you do have any voltage limiting devices, any surge suppressors, you need to let us know beforehand so we can remove them or disconnect them before the test and perform our test after that. So those are some of the EMC test failures. Next page. Yeah. Okay. All right. And lastly, things to consider. Before sending the product for testing, get familiarized with the standard test setups and requirements. You could easily get hold of the ANSI C12 standard, get hold of the 61000-4- standards. Your engineering team could set up for some of these tests in-house and try to evaluate if your product will successfully pass the ANSI requirements. Evaluate your product right from the design stage. So you want to make sure that you start testing your product as you go through the development phase, perform emissions testing, make sure you have, everything, surge suppressors are rated for the adequate rating. So as you go through your design and development phase, you want to make sure that you evaluate it against the ANSI requirements. Now the next thing, if your product is a sub-meter or a product that is not a typical electronic sub or electrical meter, if it is something that is going to be used in the field just to check for something, check for the validity of your pulses, and somebody is saying that, go ahead and perform the ANSI C12 testing, you want to make sure that you get together with your buyer and prepare a test plan, because some of the tests may not really be applicable to your product. Next is, if your product has already met some of the commercial IC EMC requirements, it doesn't mean it will pass ANSI requirements, because just because the IC requirements require testing at a much lower level, like we saw 2 kilovolts for fast transients, up to 4 kilovolts for surge, versus 6 kilovolts for ANSI and 4 kilovolts. And lastly, use the pre-testing option on high-risk tests. So after you've gone through all the checks, after you've gone through pre-testing back and forth with the local test labs, before you're even ready to submit your product for final ANSI C12 testing, you still use the option of pre-testing on some of the high-risk tests so that you eliminate the risks. Thank you. With that, I'll pass over to Jim.
Thank you, Monty. Yes, so that reminds me that we really do have a fourth meter testing program here. The fourth of sorts is the pre-testing program. It's really optional, but it can be very advantageous, particularly if you have a new design of product where there's not an awful lot of confidence that it will pass some of these more problematic tests that we see. So that would be a fourth option as well before getting into a full-blown meter certification type program. So there are, of course, additional testing for smart meters that go beyond the ANSI standards. The wireless modules, for example, they need to be tested for FCC certifications and verifications. There may be product safety type tests that need to be performed on sub-modules that are installed within a metering product. There could be issues that either the manufacturer is hearing back from field installs or utilities are seeing in the field, whereby when you're trying to sort of nail down what might be going on, it's something causing the problem that goes beyond what is required by what is in the current ANSI C12 standard. So for that, we have optional testing that is not really a part of the meter test program, but can be added on or tested before you get into a meter test program, or tested sometime after a meter has gone through. And frankly, these types of tests can be applied to several different types of products. It really doesn't even have to be meters. But we've got our product safety compliance group here. As I mentioned earlier, we are a nationally recognized testing laboratory, so that we do list products and recognize components as required by law, or in some cases buyers. We have a HALT HAS test program. The highly accelerated life testing is primarily what we get involved with when you're trying to assure that your product is going to last a long time in the field. That program will reveal weaknesses. You're stressing the product to the point where you're essentially having some failure, a hardware, a mechanical failure, some sort of failure, so that you can pull out some of the weaknesses of the product before it gets into the field. So that can be advantageous to give you a high level of assurance that the product is going to last for quite some time in the field. Can you put a number on it? It's going to last X amount of years? Generally speaking, no. But going through a HALT program such as that will greatly improve the ruggedness of the product. Failure evaluation, I just touched on it. Identifying any problems in the field. Many times the manufacturers or utility will continually see problems. Any product can fail. But when you start seeing reoccurring problems that are accumulating, and it's tough to sort of nail down exactly what may be happening, that can certainly help you try to develop a test program within the laboratory, a controlled environment, to help bring out that failure and try to get to a determination of what, in fact, may be causing that. And, of course, this many times is well beyond what's required by ANSI. Utility or manufacturer-defined requirements. I mentioned our customer-specific test programs. That would fall along those lines, where we can, again, develop a test program specifically for what you're trying to target. We also have a CT accuracy testing capability here, so we'll get into all these here. Product safety certification, again, nationally recognized testing laboratory, approved by OSHA for many product safety standards, UL 61010 being one of those, having to do with meter safety. There is a follow-up inspection with most of our listing programs, and there you see in the bottom right corner there our MET product safety mark, and of course there will be a specific standard referenced underneath of that mark as well. Again, these are optional tests, just sort of expanding on what we can perform as a part of or as completely separate from your meter certification testing. I talked about the HALT HAS testing. That's very, very helpful in ruggedizing the product. You're trying to pull weaknesses out. Essentially, you're trying to break the equipment. You break it, you fix it, you continue testing farther to try to stress the product to the point of failure to help pull out weaknesses. And at some point, enough is enough. And you know, when you get to a point where you feel like you've improved the equipment design enough, then that would be the end of the test program. So it's case-by-case basis, depending on what you're looking for. Utility problems with equipment in the field once it's deployed. Again, MET can really be an advantage for you to help develop a test program, either a certification program, an ongoing type of testing program, what have you, whatever the case may be, whatever you're looking for to help you meet the needs of either your buyer or to identify issues that you're seeing in the field. Our CT accuracy testing, there are the standards that we are able to test to, the IEEE C57.13, the IEC standards, the 60044-1 or -6, the IEC 61869-2, which essentially supersedes the others, but we still see requests for the 60044-1. And there's also an ANSI standard that has to do with CT testing as well. At the moment, we do not have VT testing, but that is something that's probably coming down the pipe before too much longer. So just wanted to list some of the changes coming up in the ANSI C12.1 2013 revision, which is still not out yet, but it should be out soon. The criteria right now in that document, in the 12.1 document, is really looking at 1% accuracy as calibrated. The standard, there's going to be 0.5 accuracy criteria added to that, and it really has to do more with the C12.20 standard, which already has 0.5% accuracy criteria in it, but there are certain meters, depending on the configuration in the field, that are not considered a Blondel meter. So you may be able to test those. Essentially, there's not a neutral reference to any of the circuits in the meter. So say for a Form 2S meter, you don't have that neutral reference in the meter. In the lab, you can test it and generally easily get compliance to the 0.5% accuracy criteria at a C12.20, but realistically, when you deploy those meters in the field, there's probably certainly going to be imbalance between the A and C circuits, which would essentially add sometimes quite a bit of inaccuracy to that meter. So that's part of the reason for bringing that 0.5 criteria into 12.1 to address those non-Blondel configurations. Definitions, there are going to be some definition updates, particularly for the balanced voltages. So there are going to be some details there defining what that is, along with some diagrams and so forth. More clarity to some of the performance requirements prior to getting into the external influence test. The external influence tests being test 15 through 38. The first test 1 through 14 are really core accuracy tests. Test 5, I don't think I really need to read through all these. I just wanted to list them for you to read. But test 5, voltage variation, there's going to be some changes there for wide-ranging meters. Some empirical rise changes to the limits out of the temperature rise criteria, along with some details on where to attach thermocouples, where to measure those temperatures during testing. So really helping better define the criteria and the procedures for running through those particular tests. Test 25, the SWC test, there was a typo in the standard. It's going to be changed from 2-minute durations to 2-second durations to bring that more in line with industry standards. Some additional accuracy checks, defined accuracy checks during the course of the operating temperature and relative humidity tests. And some additional criteria, clarity, I'll say, for in-service meter performance and criteria that you find in the back of the C12.1 standard in Section 5, along with a periodic test schedule for utilities to check meters in the field. So just a few things there that'll be updated. It may be some other things that I didn't list. So the benefits of a MET meter certification program, independent test laboratory, we're recognized throughout the industry. We try to ensure that all meters that come through the lab, and we see all sorts of types, are tested consistently, not only to the standard, but so that we're not treating one any different fundamentally than the next. Public confidence, to say that the meter was not just tested by the manufacturer, which may be fine, but to say that it was, in fact, reviewed by an independent source and was deemed to be compliant with industry standards. And, of course, industry knowledge to the updates. MET's the only certification program for meter certification. We've been testing meters well over 40 years now. We've got plenty of certification experts throughout the labs here, whether it be my lab, Monsi's lab, our environmental simulation, product safety group, wireless group. We have quite an array of capable folks here. We're certainly customer service oriented. That's our main focus, really, to work with the customer. And we have quite a few sales folk and our project points of contact that we assign to each and every manufacturer or customer that comes through our doors to help assure that they get a high level of service. We do have our searchable meter database on our website, and of course compliance evaluations to more than just ANSI with the Measurement Canada testing that we can perform, Mexico, CFE, the IEC testing. We talked about the CT test programs. So we have quite a bit to offer here at MET. Okay, with that, I think that's the end of the program, and we can take questions.
Great. Thank you, Jim. That concludes the presentation portion of the webinar. Tomorrow, an archived copy of the webinar will be available on our website. We will send a follow-up email with a link to that file. Now, we will answer questions. If you have a question, please type it in the questions area of your control panel. For questions that we can easily address now, we will read the question aloud, then give the answer. We have a couple questions that have come in already.